Welcome everyone. In this video, I will be covering section 11.8, which is power series. What is a power series? Power series is a series of the form sigma Cn x to the power n, and the expanded version of it is C0, C sub 0 plus C1x plus C2x squared plus C3x cube, and so on, where x is a variable and cn's are constants called the coefficients of the series. For each fixed x, the series is a series of constants that we can test for convergence or divergence. If you fix the x, then it will be series of constants, and we have been referring to all types of series from 11.2 through 11 section 11.7. We have seen several types of series, and we have also learned several types of tests for convergence, and we can test them whether the series is convergent or divergent for these particular values of x. The power series may converge for some values of x and diverge for certain values of x. The sum of the series is a function denoted by f of x, which is c0 plus c1x plus c2x squared and so on, cnx to the power n and so on, whose domain, now you're calling it as a function, therefore you have to talk about the domain, whose domain is a set of all x for which the series converges. Notice that f resembles a polynomial. If you look at this, the function f of x here, looks like a polynomial. Only difference is this f of x has infinitely many terms. The only difference is that f has infinitely many terms. So we are going to give one specific value for x here. If you take, for instance, if we take cn's are all 1, all these coefficients are 1 in this case, then we get a series, a geometric series, because all the constants are 1. Then we are going to get, from this step, you're going to get 1 plus x squared, etc., because all these are constants. So if I write that over here, then I'm going to get 1 plus x squared plus x cubed, nth term is x to the power n, and so on. Which is definitely a geometric series because its starting term is 1 and common ratio is the x. So you know when a geometric series converges, which converges when the common ratio lies between -1 and +1, and diverges when absolute x is more than or equal to 1, which means that when x is more than 1 or less than -1, it's or equal to 1, it's going to be divergent. More generally, a series of the form sigma Cn x minus a to the power n varying from 0 to infinity. In the expanded form, it is C0 plus C1 times x minus a plus C2 times x minus a, the whole square. This is called a power series in x minus a, or a power series centered at a, or power series about a. So that's about the power series. So for what values of x, this is example 1, we are going to find out what values of x is the series sigma n varying from 1 through infinity with factorial n times x to the power n convergent. So what values of x will make it convergent? So because of the fact that it is involving factorial n, we usually go for the ratio test. So apply ratio test. So we get an, which is without the sigma, which is factorial n times x to the power n, a sub n plus 1, n plus first term is n plus 1 factorial x to the power n plus 1. So in order to apply the ratio test, we have to consider the ratio a sub n plus 1 over a sub n, which is factorial n plus 1 times x to the power n plus 1 divided by factorial n times x to the power n. So as we normally write, n plus 1 factorial, just like 5 factorial, can be written as factorial 4 times 5. So we can write this as n plus 1 times n factorial x to the power n plus 1 divided by factorial n times x to the power n. So we can cross these guys out. It's x to the power n, x to the power n plus 1. That will throw just x on the numerator. So we get here, it's just n plus 1 times x. Then if you take limit n approaching infinity of a sub n plus 1 over a sub n, which will be limit as n approaching infinity of n plus 1 times x. N plus 1 is always positive, so you can take it out of the absolute sign. So it is limit as n approaching infinity of n plus 1. You don't need that absolute sign there, but here you have to put the absolute sign. The n is approaching infinity. So this is going to be infinity. This is going to be infinity whenever x is not equal to 0. Otherwise, it would become indeterminate. So whenever x is not equal to 0, it is infinity. So what it means is, the ratio test says that if an plus 1 over an, the limit of this is L. And if that L is more than 1 or infinity, then the series diverges. So we say that the series diverges here whenever x is not equal to 0. So by ratio test or conclusion, or you can also consider this as a concluding step, by ratio test, the given series factorial n sigma factorial n x to the power n diverges for all x not equal to 0. So where does it converge? This means that it converges only at x equal to 0. Converges only at x equal to 0. Also, you can check that when you plug in x equal to 0 here, sigma, this is kind of a check. Sigma factorial n x to the power n varying from 1 through infinity. So it is, the terms are x, when you plug in n equal to 1, it's factorial 1 x to the power 1. Factorial 1 is 1. Then you have x square, then x cube, factorial 1, factorial 2, factorial 3, factorial 4, x to the power 4. You notice that when x equal to 0, all the terms become 0, right? When x equal to 0, the series, the whole series becomes 0. So it is convergent when x equal to 0. The only point at which the series converges is x equal to 0.